Dear my students, today we are going to study a new lesson which is wave effects. By the end of this lesson, you will know what is meant by reflection, refraction and diffraction. Reflection. Reflection of a wave resulted when it strikes a plane surface. The surface may be tough or smooth. So we have two types of reflection: regular reflection and irregular reflection. Regular reflection resulted when a wave strikes a smooth surface. In this case, the incident rays are parallel together and reflected rays also parallel together. This reflection occurs in mirror. Second type of reflection is regular reflection. This reflection resulted when a light ray strikes a tough surface same in sheet of paper. In regular reflection, the incident rays strikes parallel but reflected rays divergent. This for reflection of a wave. Reflection in a plane mirror. In this figure we have a plane mirror and a light ray strikes on this plane mirror. This ray will reflect as we see. So we have incident ray and reflected ray. The line that acts perpendicular to the surface of mirror called normal, and the angle between incident ray and normal called angle of incidence, and the angle between reflected ray and normal called angle of reflection. Laws of reflection. There are two laws of reflection. They apply to all types of mirror, not only on a plane mirror. First law states that the angle of incidence equal to angle of reflection. Angle of incidence I equal angle of reflection R. Second law of reflection is stated that the incident ray, reflected ray and the normal all lies in the same plane. So we have two laws for reflections. Concentrate. Incidence angle mean the angle between incidence ray and the normal. Reflected angle refer to the angle between the reflected ray and the normal. Now we will solve these questions related to laws of reflection. A light ray strikes a reflective plane surface at an angle of 56 degrees within the surface. Find the angle of incidence, find the angle of reflection. As we see in this figure, 56 degrees refer to angle between incident ray and the surface. So this angle not refer to the incidence angle. Incidence angle calculated by 90 minus 56, because the angle or total angle between normal and surface equal 90 degree. To calculate I equal 90 minus 56 equal 34 degrees. Second question, find the angle of reflection. From the first law of reflection, incident angle equal reflected angle, so reflected angle equal 34 degrees also. Refraction. Refraction resulted when a wave travels between two different and transparent mediums, because the speed of light or speed of waves will change. Speed of waves depend on the type of mediums. It differs from medium to other. Refraction occurs because the speed of wave changes. Speed of wave different in different medium. In this figure, this pen appears broken because the light traveled from water to air, so speed of light changed. The speed of light in water less than speed of light on air. So the light ray travel from low speed to high speed and light ray refracted. Refraction of light. We know that refraction occurs when the light ray travels between two different and transparent medium. As we see in this figure, we have incident ray. First medium is air, second medium is water. This ray refracted as we see in the second medium. So we have incident ray, refracted ray, normal, incident angle, and refracted angle. Incidence angle acts between normal and incident ray. Refracted angle acts between refracted ray and the normal. We have two cases for refraction. Refraction may occur near the normal or away from the normal, depending on the speed of wave. First case, when light ray travel from high speed medium to low speed medium, it will refract near the normal. Same when the light ray travel from air to water, it will refract near the normal. Second case, when light ray travel from low speed medium to high speed medium, it will refract away from the normal. Same when it travel from water to air, this case the refraction occur away from the normal. Real and apparent depth. Because of refraction, water looks less deep than it really is. Its apparent depth is less than its real depth. This diagram shows two fishes, but only one is the real one and the other is apparent one. This is because refraction of light. Also because the speed of light changes. In this case, the light travels from water to air, so its speed will increase. It started from low speed and its speed will increase in air. This change in speed causes the beam of light to bend. This causes the real and apparent depth. Refractive index. Refractive index defined as the ratio between speed of wave in a vacuum and its speed in medium. Refractive index formula: N equal speed of light in space divided by speed of light in medium. Also, refractive index can be calculated by using the incidence angle and refracted angle. N equal sin I divided by sin R. This law called Snell's law. So, refractive index can be calculated by speed of light in space divided by speed of light in medium, or sin incidence angle divided by sin refracted angle. No unit for refractive index. Refractive index has no unit because it equals speed over speed or angle over angle. This question is very important related to Snell's law. A diver shines a flashlight upward from beneath the water at 31.7 degrees angle to the vertical. At what angle does the light leave the water? So the givens are refractive index of water and incidence angle. We want to calculate the refracted angle. To calculate refracted angle, we will use Snell's law. N equal sin I divided by sin R. Refracted index or refractive index is given, which is 1.33 equal sin 31.7 divided by sin R. To get sin R, cross multiplication, so it will equal sin 31.7 divided by 1.33. So sin R equal 0.40. We need to calculate R, not sin R. To get R, we will use inverse sign. By your calculator, press shift sign. So R equal sin inverse 1, 0.40. So R equal 23.58 degrees. The refracted angle equal 23.58 degrees. The last effect of wave is diffraction. Diffraction occurs when bend around the side of an obstacle or spread out as they pass through a gap. We have two factors affecting the diffraction. First one, the size of gap. Second one is the wavelength of the wave. Firstly, size of gap. The relation between diffraction and size of gap is inversely proportional. As size of gap decreases, diffraction will increase. As the size of gap increases, diffraction will decrease. So, diffraction depends on the size of gap. Second factor is wavelength of a wave. As wavelength of a wave increases, diffraction also increases. So directly proportional between wavelength of a wave and diffraction. This is the end of our lesson. Try to solve the homework that uploaded on a model. Thank you.